Okay, I'd say let's start. Hi, everyone. Can you hear me? Oh, it's up. Can you hear me now? Okay, perfect. Hi, everyone. Thanks for joining. This is a tutorial on purpose limitation and data minimization and data-driven systems. My name is Biega. I'm a tenure-track faculty member at the Max Planck Institute for Security and Privacy. And I'll be presenting this tutorial jointly with my colleague, Michèle Finck, who is a professor of law and artificial intelligence at the University of Tübingen. She's joining us remotely today. I want to start with a brief overview of what this tutorial is going to be about. The tutorial is based on one of our recent papers published last year in Technology and Regulation. So if you're interested in more details, please refer to the paper that I'm listing here on the slides. We're going to begin with this tutorial with definition of purpose limitation and data minimization in GDPR. GDPR is the European Union's General Data Protection Regulation. We're going to provide an overview of the legal debates about the desirability of the two principles. We're going to then proceed with an overview of the computational evidence that we have gathered that makes us think that data minimization could be implemented to a larger extent than it currently is in practice. We're then going to move on to discuss purpose limitation in more detail, and this is going to include the legal theory and components of purpose limitation. That includes specificity, explicitness, legitimacy, and compatible use. We're going to provide some evidence of the current implementations by online platforms and discuss recent computational approaches that define purpose in data-driven systems as service improvement. We're then going to discuss data repurposing that will include the means and conditions under which service providers can repurpose data, and that includes scientific research, statistical purposes, and consent. We're going to overview the associated practical challenges. So a teaser here is that we found that beyond the computational and legal challenges, there could be potential relationship between an organizational structure of a company and their ability to repurpose data. We're then going to discuss data minimization, and that also is going to include the legal theory and components of data minimization, and those are relevance, adequacy, and necessity. We're going to discuss different types of data minimization, minimization of data quantity and quality, minimization of special categories of data, and we're going to provide some evidence of current implementations by platforms and describe recent computational approaches, challenges, and open questions. At this point, we'll be ready to discuss the more general trade-offs in data protection that have been exemplified by our work on purpose limitation and data minimization. And we're going to end with an outlook, discussing some short-term recommendations for practitioners and long-term research questions we think are necessary to answer so that data minimization can be meaningfully implemented in data-driven systems. With that, I would like to hand over the virtual mic to my colleague, Michèle.
Hi, everyone. It's a pleasure to join you remotely today. So let me share my slides. Right, so I'll start by saying a few words about the background of our paper, and I think this, in this context, specifically means the... yeah?
Wait, oh, perfect.
Can you hear me?
We can hear you, sorry, we just have to switch the slide, slide display.
All right, I'll wait and...
Yeah, we can see your PowerPoint, but you probably have to go to the full screen mode. Yeah.
Can you see it now, and can you hear me?
Yes, perfect.
Okay, perfect. So we're good to go now. So, right, I'll start again. So I'll be starting by saying a few words about the background of our paper, and I think in this context, this specifically means the sort of two legal principles that we're looking at in this paper from an interdisciplinary law and computer science perspective. So the two principles that we're examining are purpose limitation and data minimization. And I'd say that those are not just sort of two legal principles in data protection law, but they're actually two of the most foundational principles in data protection law. So they are listed in Article 5 of the EU's General Data Protection Regulation, the GDPR, and Article 5 is sort of like generally understood to enshrine the so-called core data protection principles that ought to be respected whenever a data controller processes personal data. And the purpose limitation and data minimization are also sort of really foundational to the extent that they have for a long time been part of EU data protection law. So sometimes there's an assumption that EU data protection law is only as old as the General Data Protection Regulation itself. That is to say that data protection only emerged with the GDPR when it became binding in 2018. But actually, data protection law is much older than this. So it goes back to a directive of the European Union from 1995. And even that directive was based on various member state laws that had come into existence from the 1970s onwards. And both purpose limitation and data minimization have really been part of data protection law from the beginning. So they're really important foundational components of that regime that apply whenever personal data is being processed by a data controller and irrespective of the context in which this is happening. So in a nutshell, we can describe purpose limitation as an obligation for data controllers to identify a purpose, that is to say a reason or an objective, why personal data is processed. And similarly, data controllers can process personal data beyond that predefined purpose. Data minimization, in turn, requires that no more personal data than is necessary to achieve this purpose that has been predefined in accordance with the purpose limitation principle is processed. So I'll, of course, talk about those principles in more detail and give a more detailed legal overview of what they require, what they entail, and what their components are. But before moving on to this more detailed part of our analysis, I want to provide some more background and explain why we thought it'd be interesting to actually study those two foundational data protection principles in our paper. And I think the main reason for this is that in recent years, we've seen lots of debates that suggested that purpose limitation and data minimization are outdated. That they go back to a data economy that is unlike what we have today, and that it is actually impossible to implement purpose limitation and data minimization in contemporary data processing systems. So arguments have been made that lots of recent advances in machine learning have been achieved through the repurposing of large quantities of personal data. Which, of course, at least at first sight, seems to be at odds with both purpose limitation and data minimization. And as a result, we've actually seen a lot of calls, both during the time that the GDPR was negotiated, but also in the aftermath of this, that those two principles, no longer can be realized in practice. And some people have suggested that as a result thereof, they should be removed from EU data protection law. So we've, of course, followed those debates, and we thought it'd be worthwhile writing an interdisciplinary paper that examines whether those claims are really true and whether it is actually impossible to comply with those two principles in contemporary machine learning systems. Then there's also another reason why I think it's a particularly good moment in time to actually study those two principles from an interdisciplinary perspective. And this relates to changes that we are observing in the European Union's data law framework. So at this stage, we have a robust and long-standing data protection law regime. But at this moment in time, the EU is actually negotiating, or the various institutions of the EU lawmaking process are actually negotiating new instruments of European data law. Those are things such as the Artificial Intelligence Act, the Data Governance Act, the Data Act, the Digital Services Act, and the Digital Markets Act, that would significantly change the shape of European data law. And what unites those new proposals is that they all create incentives to process more data in the EU in the hope that this is going to increase the competitiveness of the European Union's internal market. And once those norms become binding, I think you'll have a very interesting situation, to the extent that there is going to be a much bigger framework of European data law that goes beyond data protection law, and that enshrines both incentives to process more data, as is being done through things such as the Data Act or the Data Governance Act. But of course, data protection law, and particularly purpose limitation and data minimization, are rather incentives to process less personal data, right? So I think the reconciliation of those various dynamics and the role of purpose limitation and data minimization vis-a-vis those new legal frameworks is something that's going to be fascinating to observe in the years and decades to come. And the hope was that our paper could, start to kick off some of those debates. Then there's a third reason why we thought this would be a good research project to do, and this is the fact that there's actually very little existing literature on the practical significance of data minimization and purpose limitation in specific technical environments. So we thought it'd be a good idea to sort of give a bit more, provide some more empirical and factual groundings to the debates that are happening as to whether it is or is not possible to implement purpose limitation and data minimization in relation to machine learning systems. Right, so I'll stop here, and I'm handing back over to Asha.
All right, now back to the computational perspective. What got me as a computer scientist really interested in the topic of data minimization were exactly these claims that data minimization is not really feasible anymore, that we live in a world of big data, that business models rely on huge amounts of data we collect, and that machine learning models need all of this data to produce quality results. Yet, during the research we did for this paper, we managed to find empirical evidence in the computer science literature suggesting that this might not be universally true, that as we collect more data, we quickly reach diminishing returns in terms of model performance. For example, in this paper from 2008, this is a paper focusing on personalized search. Researchers looked at how the utility or the quality of the personalized search model changes as we include more and more features about users. So here on the x-axis, these are different features which are ordered greedily according to their contribution to the overall quality of the model. And the researchers in this paper observed this diminishing property here, to the extent that at some point it looks like new data does not really add any value anymore, at least in terms of what this particular model can do. And we've seen similar evidence suggesting diminishing returns in other areas as well. Beyond personalized search, we found some papers showing this property in natural language processing, in computer vision, in deep learning, or in deep learning as a technique more generally. For example, we found this paper by Hesnes et al. And this is a paper on deep learning scaling, which shows the existence of 3 different stages of model performance throughout data collection. The first stage that they identified, they called small data region. This is where the model has not learned the data distribution well enough yet, and the error remains high. Then there is the power law region, where the collection of additional data improves the model. So this is the stage where we can think of trading more data for improved model performance. And finally, there's the stage which they called the irreducible error region, where the inclusion of additional data yields little to no return in terms of model performance. And that's a stage that could be thought of as most problematic from the perspective of data minimization, because we cannot really argue that we need this data to improve this particular model. And we have observed similar performance stages in the context of recommender systems as well. If you're interested in learning more about this work, my colleague Divya will be presenting this paper at FAccT tomorrow. All right, so we saw some empirical evidence suggesting that models might not need all of the data that we're collecting, but do we have computational techniques that we could use to limit data? And the answer is, we'd argue also yes. We do have a lot of computational techniques that in fact can be seen as minimization techniques. Examples include, for example, outlier detection, a technique we apply to remove noisy data. Feature selection is another technique where we remove certain features, for example, redundant features from the data before we train a machine learning model. We use a technique called active learning to selectively label data before we feed it to a machine learning model or as we train it. And these techniques have not been applied in the specific context, in the specific legal context of data minimization. They were developed towards different ends. So some of these goals include improvement of model performance or reduction of costs in terms of data annotation or data storage or compute time. So there are 2 lessons here. First, that data minimization might actually lead to better model performance and give certain benefits to data processors as well, such as decreased storage costs or processing costs. And second, we definitely do have techniques that look promising, but these techniques have not been applied in this specific context, or at least we know of very few papers that have applied techniques like this in the context of the legal data minimization. And so they might need some work and they might need some research to be adapted towards legal compliance. Even beyond more sophisticated algorithmic techniques, one can think of simpler heuristics for retaining data. For example, we could systematically discard old data while retaining new data that is coming into the system. We found some papers, for example, in the area of recommender systems that show the feasibility of this technique. And generally, one might expect a strategy like this to perform well when user characteristics and behavior and preferences change over time. And so discarding old data might help systems keep user models up to date. In fact, we have observed that some online providers now do this. One of the recent changes in Google's data retention policy, where a web activity of new users that are joining the system will be by default deleted by 3 or 18 months, suggests that a strategy as simple like this might be effective in industrial practice as well. All right, so effects of limiting the quantity of data are only one of the sources of disagreement about the desirability of data minimization. Several studies have shown that it's also possible to reduce the quality of data without reducing its overall quantity. So, for example, in one of our old papers, we demonstrated that it might be possible to achieve good levels of personalization for search and recommendation, while randomly shuffling user data into synthetic user profiles. And the data here means user search queries or product ratings in a recommender system. We would do this under certain accuracy constraints to sort of balance the need for data minimization in terms of data quality and the accuracy of the resulting model. And similar techniques have been adopted to show the feasibility of such data shuffling and synthetic profiles in online communities as well. So effectively, approaches like this would allow a system to retain the overall volume of the data that they collect and preserve system accuracy, for example, have accurate analytics over the user data that they're collecting, but they would be minimizing the quality of the aggregated user profiles. We have also seen some work with architectures in which a user data resides on their local device, while only crude, more aggregated data is shared with service providers on a need-to-know basis. And the feasibility of these types of algorithmic architectures have been demonstrated, for example, for personalized search, where a user shares only high-level topical categories of interest with the service provider. And we have seen similar architectures for recommender systems, where, for example, we have a local tool which advises the user of whether to share their product ratings or clicks with a recommendation provider based on some local privacy utility analysis. And more generally, a local device distributed learning paradigm called federated learning is an active area of research in computer science as well, and can be seen as a minimization technique. All right. Despite the promise of computational feasibility, we also found that data minimization can lead to certain unanticipated consequences for both users and service providers. Even if limiting quantities of data might lead to little accuracy loss at an aggregate level, we have seen studies, and one of our old papers shows that the data limitation could impact individual users or different demographic groups to a larger extent in terms of the quality of the service that they're receiving. And so this raises the question of what data minimization might mean in terms of fairness. Second, minimization might lead to disparate data collection burden across users. And again, this is something we show in a paper that's going to be presented in one of the sessions tomorrow. Minimization of sensitive attributes has furthermore been shown to hinder the capacity of service providers to audit fairness in personalized products, for example, in recommender systems. And finally, we found that algorithms exhibit different levels of robustness to data minimization. And this raises the question of how limitation obligations would impact different service providers, and whether this impact would depend on how complex or state-of-the-art their algorithms are. All right, so just to summarize this introductory part with some evidence suggesting that we could be doing more in terms of data minimization. We found some empirical evidence showing that we might need less data than we collect. We found that we have computational techniques we could adapt to minimize data. And the question that motivated me to pursue this work is, why is data minimization not being implemented to a larger extent then? And with the question at the back of our heads, it's time to dive deeper into the principles of process limitation and data minimization. Michèle?
Right, so yeah, sorry, just activating the slide. So let's start by looking more deeply at what purpose limitation as a legal principle actually requires. So I think the first point to note is that purpose limitation is actually explicitly mentioned as a component of the fundamental right to data protection in Article 8, Paragraph 2 of the EU Charter of Fundamental Rights. So to provide some context about this, for those of you that are not lawyers or not familiar with European Union law, the fundamental right to data protection as formulated in the EU Charter is, of course, much shorter than the General Data Protection Regulation, which is a pretty huge piece of legislation. And so it's quite significant for purpose limitation to be mentioned as sort of one component of purpose limitation in the charter, right? I think this really goes to show that purpose limitation and then its cousin of data minimization are really central to the right to data protection. And this mentioning by the EU Charter of Fundamental Rights is also interesting to the extent that it means that if you wanted to abolish purpose limitation from the body of EU data protection law, as some people have claimed should be done, it wouldn't be enough to change the GDPR, so a piece of secondary legislation, but you'd actually need to change the EU treaties, which of course is, from a political perspective, an even more an even bigger, and I would even say, even more unrealistic perspective, right? So it's really an indication that purpose limitation is here to stay, and that we need to find ways of incorporating it into contemporary data processing systems. Now, let's look at what purpose limitation actually specifically requires from a legal perspective. And this we find in Article 5, 1b of the General Data Protection Regulation. And here the text tells us that personal data can only be collected for specified, explicit, and legitimate purposes, and shall not be further processed in a manner that is incompatible with those purposes. Further processing for archiving purposes in the public interest, scientific or historical research purposes, or statistical purposes shall, in accordance with Article 89, Paragraph 1, not be considered to be incompatible with the initial purposes. So I essentially want to break this chunk of text apart in order to get a better understanding of what purpose limitation requires from a legal standpoint. And the important thing to note here really is that the general principle of purpose limitation can be broken down into two distinct requirements. The first one is the requirements of purpose specification, right? So this relates to the very first part of Article 5, 1b, namely that data must be collected for specified, explicit, and legitimate purposes. And then the second legal requirement that derives from this broader principle of purpose limitation is compatible use. And this relates to the second part of this first sentence, namely the fact that data, personal data, shall not be further processed in a manner that is incompatible with the initially defined purposes. Now, what do purpose specification and compatible use imply in practice? Let's start by looking at purpose specification. So under the requirement of purpose specification, EU law requires that the data controller defines a purpose before any data processing takes place, right? This is important. So it's actually the specification of the purpose is a step that must precede the actual processing of data, and processing as defined in EU law includes the collection of data as well, or the storage of data as well, right? So before a data controller actually does anything with personal data, the purpose limitation principle requires that they first define what the objective of processing this data is, right? So it really forces data controllers to sort of like, sit down and think about, well, what will I do with this data? And in doing so, they must respect three distinct criteria. So first of all, the purpose that is identified must be specified. So essentially, it means that it must be sort of communicated, right? In most cases, this means that the purpose needs to be written down somewhere in terms and conditions, or in other contexts, but it needs to be specified in a form that is possible to communicate to data subjects as well, and that is visible to data protection authorities, for instance, as well, in case there's ever an investigation or similar action. Then second, the purpose that is identified must be explicit. And explicit essentially means that it can't be too general. And we have some guidance of the Article 29 Working Party, which is the predecessor of the European Data Protection Board. The European Data Protection Board is essentially an organization at EU level that does many things in relating to data protection, including the issuing of guidance as to how certain concepts are to be interpreted in data protection law, or how data protection law maybe ought to be applied to specific technologies, etc. And this institution has issued some guidance a couple of years ago on the purpose limitation principles. And in this guidance, it explains what an explicit purpose is. So it states that purposes such as, improving user experience wouldn't be explicit enough to actually meet the legal standard. Similarly, where data controllers would say that they are processing personal data for commercial purposes or for advertising, would not be specific enough either, right? So essentially, it needs to be a more detailed description of the purpose. But I think this is also important to bear in mind. The assessment of whether purpose is sufficiently explicit is always contextual, right? So you need to take into account a number of factors, including, who the controller is and what the context of processing is. And there's certainly a higher threshold for, large companies processing large quantities of certain personal data than there would be for, say, a local sports club. When it comes to defining the purpose in an explicit way. And then the third criterion is the legitimacy criterion. And this essentially means that you can't process personal data for a purpose that is unlawful, right? So you can't have a purpose specification that says, we are processing your personal data in order to better advertise a certain hard drug that is illegal to you. That would be an illegitimate purpose. But needless to say, this is something that's generally not relevant when it comes to determinations of purpose specification in commercial contexts using machine learning, and also something that's covered by other laws as well. So what we can see from this is that with the exception of legitimacy, the other components of purpose specification, namely specificity and explicitness, are essentially procedural requirements that can, in general, I think, be met by skilled legal drafting, right? So I think most good data protection lawyers will be able to sort of create a good specification of any purpose. And as such, they don't really limit how personal data can be processed, right? So I think purpose specification in itself doesn't really lead to a limitation of what you can do with personal data. It just creates some procedural requirements around the use of this data, which in this case force the controller to essentially, I think, be mindful about what they're doing with the data, right? So really, think about what your objective is in processing that data. And correlatedly, that also create transparency for data subjects as to why their data is being processed. And this actually connects well to the fact that purpose limitation is one of the core data protection principles enshrined in Article 5 GDPR, because transparency would be another core data protection principle that we find in the same provision. So purpose specification in and of itself doesn't restrict really how personal data can be used, at least not to the extent that the usage is legitimate. Compatible use is a bit different. So as I mentioned in the beginning, purpose limitation can be broken down into both two distinct legal requirements, purpose specification on the one hand and compatible use on the other. And compatible use essentially means that personal data cannot be further processed in a manner that is incompatible with the original purpose, right? So once you define the purpose, say a data controller states that they're processing personal data for medical research, then the law imposes pretty impactful limits on further processing that can take place. right? So where that data controller would like to maybe process this data subsequently in order to, I don't know, better advertise a certain lifestyle product to you, or better advertise, I don't know, some food products to you, etc., that would likely be incompatible with the initially defined purpose. However, I think it's also important to bear in mind that regulatory guidance has really made it clear that the mere fact that data is being processed for another purpose does not automatically mean that this processing is incompatible with the initially defined purpose. Rather, this is again a contextual analysis that needs to consider first the relation between the initially defined purpose and subsequent purpose processing. Secondly, the context of collection and data subjects' reasonable expectations in relation to this context. Thirdly, the nature of the data that is being processed. So, questions as to whether this is maybe sensitive personal data as defined by Article 9 of the General Data Protection Regulation. This would include things such as data about your health or maybe about your sexual orientation. As well as the impact of the processing. And finally, the safeguards that have been adopted by the data controller around this processing. So in a few minutes, I'll be saying more about sort of possible exceptions to the compatible use requirements. We'll be seeing that there's some specific context in which the general data protection foresees that it should be sort of easier to process data beyond compatible use. But for now, I'll stop here, and Asha will tell us more about the computational perspective on purpose limitation.
Right. In our research for this work, we observed that service providers often state that user interaction data in data-driven systems is collected to provide, improve, or personalize their services. But we think that some of these purposes are in fact not very well grounded in current computational practice, as it is not immediately clear whether and which data actually is necessary to improve service results. Think about systems such as web search or recommender systems. First of all, it is crucial to observe that in such systems, ongoing collection of user data is often not necessary to provide the service. Instead, user data is used to improve the results. In web search, for example, a ranking of web pages can be computed by matching keywords in queries to words appearing in web pages. And then, while processing of a search query might be necessary to complete a given search transaction, it might not be necessary to store that query for future use once the search task is complete. In fact, we have seen personalization audit studies from a couple of years ago that have shown that there is very little personalization based on search history in major search engines. Beyond web search, in the domain of recommendations, results could be unpersonalized and based on external data. For example, we could use sales statistics of cinema tickets as a popularity indicator for recommending movies. We could even provide random recommendations. So personalized data is not necessary to provide a service, but it might be needed to improve a service. And service improvement could be considered an objective criterion for purpose formulation in data-driven systems if it satisfied the three requirements that Michèle has just discussed, the legitimacy, explicitness, and specificity. Determining whether improvement of a service is legitimate could perhaps be thought of as conditional on the legitimacy of the service itself. So in most cases, we could assume that improving a legitimate service might be considered legitimate as well. Explicitness in the case of data-driven systems could be enhanced by strategies previously proposed for other types of data, such as cookies. We could, for example, specify purposes in a machine-readable format, which, as argued by Coops, could force data controllers to reflect on their processing goals explicitly. Other approaches that have been proposed to improve explicitness of browsing cookie purposes suggest listing them in a structured table in a data processing policy. And this is a technique that allows for quick identification of processing purposes. And so solutions along these lines would appear viable for data collection purposes and data-driven systems as well. What about specificity? Our research for this paper has revealed that statements like improving user experience are unlikely to pass the specificity test. So the question is, how do we define data collection purposes in data-driven systems which are more specific than this? Von Grafenstein has argued that purpose standardization is something that could aid in increasing purpose specificity and legal certainty, because then everyone can be reassured that all data processing occurs under comparable conditions. In the spirit, browsing cookies, for browsing cookies, researchers proposed using ontologies of purposes to both standardize purpose descriptions and to allow for reasoning about ontological relations between purposes, for example, subsumption. Right. Purposes must be specifically defined, but at the same time, they should also be understandable by data subjects. And to achieve both goals, one might in practice use layered notices. And in a layered notice, we would have more general statements providing an overall explanation of what is going to happen with the data, and more detailed statements offering sufficient granularity, perhaps for users who have a better understanding of what is happening behind the scenes in a given system. Some of the recent approaches, some of the recent computational approaches to purpose limitation in data-driven systems interpret purpose as improvement in system performance. This is something I have already mentioned. But there are many remaining questions as to what that might actually mean in practice and how to improve specificity under this particular interpretation. We could think about improving specificity along two dimensions. What's going to improve and how it's going to happen. Increasing specificity along the what dimension might entail defining which functionality in the system would exactly be improved. For example, the layered description I mentioned might generally indicate improvements in personalized search, and within that purpose, we could specify for which topics a data subject could expect improvements in their search results if certain types of queries are collected and retained. Then increasing specificity along the how dimension might entail specifying how improvement is going to be quantified. For example, the goal of a search system might be to display relevant documents higher in the ranking results than they would be without the collected personal data. We could even go one step further, because when we say improvement, that still sounds a bit ambiguous, and we might need a more computable definition in practice. Generally, it is reasonable to assume improvements would be quantified as differences in selected system performance metrics. Why this assumption? Performance evaluation is widely used to judge computational systems and models. We do this in scientific publications. We do this to measure progress in the field through public benchmarks. We do this to determine whether updates to tech products should be shipped using techniques such as A/B testing, for example. And practically, to form a quantitative basis of purpose, it would remain to be determined which metrics to choose, how to obtain their values in practice, and which level to aggregate metric differences at. There are certain challenges related to the selection of a metric. A metric would have to be selected from a set of metrics that often guide system quality measurement jointly. And the main reason for such complex evaluations is that different metrics capture different aspects of system performance, and often none of these aspects are more important than others. And the selection will be hard since individual metrics in this evaluation set will often disagree as to whether a given change or an additional piece of collected data leads to service improvement or degradation. Here, it is also important to acknowledge that metrics often serve as simpler quantifiable proxies for measurement targets. For example, in systems such as search and recommendation, the goal might be to improve user satisfaction. And user satisfaction is typically approximated using simpler measurable concepts, such as the number of clicks. So it's important to recognize the consequences and limits of using such proxy metrics to determine which data should and should not be collected. All right, the second question is, how do we get the values of performance metrics in practice? They could be obtained using quantitative or qualitative evaluations. For example, in personalized search, the goal of a system might be to reduce the time necessary to find the desired piece of information. And whether the system achieves this goal might be measured quantitatively using the rate of search query rephrasing. Because in information retrieval, it has been shown that when a user rephrases their query, that often means that the previous query has likely not yielded satisfying search results. Or we could evaluate qualitatively through either an in-person user experience interview or an online survey. And finally, there might be multiple approaches to aggregating metric improvements. Among the many possible options, a formal purpose definition might require that the collection of data improves the service on average for all users, or that the collection of data improves the service for the individual for whom we're collecting the data. And because of all of these complexities, more detailed guidance will be necessary for practitioners to navigate all of these different choices, design choices, because all of them might lead to different minimization outcomes. Right, now we're ready to move on to the next segment on repurposing data. Michèle, do you want to start? We have around 8 minutes before the break.
Right, yeah, I'll be short. Quick. Okay, so as I sort of finished the last chunk of my presentation, explaining that there's this compatible use requirement. So essentially, EU law tells us that, as a general rule, you can't process personal data beyond the predefined purpose. And that is a much stronger restriction on processing personal data compared to purpose specification, to the extent that this is actually a substantive limit as to what you can do in relation to personal data, unlike the purpose specification principle, which I think is much more procedural in nature, and it can be sort of drafted around, if I dare put it like that, in some circumstances. So what does this mean, right? So what does this mean in practice if you actually want to repurpose personal data for a purpose that is not sort of included or close enough to the initially defined purpose? Well, one option would be to anonymize the data. However, we all know that this isn't a solution in all contexts, to the extent that, there might be scenarios in which anonymous data is simply of no use for what you want to do with the data. And also anonymization actually has lots of risk and uncertainty, to the extent that it's very difficult to sort of determine what successful anonymization would actually be from a legal perspective. And there's at this stage lots of computer science and legal literature that supports this. So what does this mean for people that want to sort of like repurpose personal data in practice? Well, the GDPR itself actually acknowledges that there are scenarios in which it should be easier for data controllers to process their data, to the extent that, in those scenarios, it should be possible to have for the subsequent processing to have less obvious link to the initial purpose. And the first exception is scientific research, right? So the GDPR explicitly acknowledges that it should be easier to repurpose personal data where the objective of the repurposing is scientific research. This then must be in accordance with the safeguards that are set out in Article 89 GDPR. And those safeguards include both technical as well as organizational safeguards. There's some variety in relation to how this works in practice exactly, to the extent that the GDPR allows the member states of the European Union to adopt legislation that would restrict the rights of data subjects in this context, right? So this is sort of like an island of the GDPR that's a bit less harmonized than the overall scheme. And one of the questions that we are asking in the paper is, how can we actually apply this scientific research exemption to contexts where data is being personalized for commercial purposes, right? And if you read the text of the GDPR, and if you think about its history and the context from which it emerged, I think it's quite clear that what the drafters of this legislation initially had in mind is that scientific research is something that is happening sort of in isolation from other purposes, right? So scientific research is defined broadly to the extent that it can be both say research, publicly funded research in a university setting, but there's definitely also acknowledgement that this can be private research. But one of the questions that we are asking in the paper is, can the scientific research exemption apply to, say, a team in a tech company that is made up by various computer scientists, one of which has the title of a research scientist, for instance, right? Is this covered by the scientific research exemption or not? And we provide some examples of companies where you have those much more hybrid team and department structures, where there isn't necessarily sort of a strict distinction between the purely commercial arm and the purely research arm. So we can imagine this being one of the practical implications of the scientific research exemption that will attract more attention in the years to come. Then the second exemption that we're looking at, or the second sort of opening in the GDPR that we're looking at, in which it is easier to repurpose personal data, is that of statistical purposes. And again, looking at historical context, I think it's quite clear that originally the drafters of the GDPR had in mind sort of classical statistics context, where maybe using census data in order to draw up statistics about overall population demographics, etc. And we're connecting this to the discussion as to the similarities and overlaps between machine learning and statistics. And essentially in the paper we were asking, well, if we were to consider that machine learning is a form of statistics, can then this opening apply to any form of machine learning? And essentially here we have some regulatory guidance that indicates that statistical purposes can never be applied where you using an individual decision, or where you sort of like deriving an output that is then applied to an individual, right? So essentially you could argue that where a company uses machine learning in order to predict overall customer churn, then that might be statistics. But the application of this specific output to a particular customer would not be able to qualify as statistical purposes from the perspective of the law, and hence would not be able to benefit from this broader or laxer regime. And then there's a third opening that we examined in the paper, and I should say that this is by far the most controversial, right? So I think there's general agreement that scientific research and statistics is something that can be desirable from a societal perspective, that it's something that the law probably wants to encourage because of the tremendous benefit that can come from these kinds of data processing. The third opening that we're considering is a bit different. This is data subject consent. So under the GDPR, it is possible for data subjects to consent to processing of personal data that would otherwise not be compatible with the purpose limitation requirements. And this is much more controversial to the extent that data subject consent has become an overall really controversial component of European data protection law, right? So there's various grounds that can legitimize the processing of personal data. Consent is one of them. And there's many authors that are claiming that consent is actually of little use in the contemporary data economy, to the extent that it is overall impossible for data subjects to understand what they actually consent to, right? So Article 7, Paragraph 4 of the GDPR, for instance, requires that consent must be freely given, and there's literature asking, well, can this really be the case in the context where you're sort of like agreeing to terms and conditions without being in a position to understand the both technical but also economic complexity of what is happening to the data afterwards. So this is I'd say much more controversial opening that we find in the GDPR. And we can discuss this further afterwards, but I'll stop here because I don't want to keep anyone from the break. So.
Yeah, I think it's time for the break. We have 15 minutes now, and we continue with a computational perspective of repurposing. Okay, Michèle, I'll see you in 15 minutes. Hi.
I have some questions.
Sure.
Thank you. My name is Biega. I'm at TU Delft. I work on, I call it voice activation, but the two parts that constitute voice activation is keyword spotting, so the okay Google, hey Siri, and then voice biometrics or speaker verification. And so I've started recently engaging a bit with that. Well, I guess speaker verification and speaker identification together make up speaker recognition, together with speaker diarization, which determines who speaks. So those are kind of three core tasks in speaker recognition. The speech technology community considers that as voice biometrics. And so kind of via voice biometrics, I've started working a bit with also started looking a bit at the EU AI Act. And so quite recently, before coming here, the European Association of Biometrics had a workshop on the EU AI Act, particularly because biometrics is a prohibited category, so I guess it's quite important to them. And so, okay, that's the preamble. I'm really loving this tutorial. That's maybe the other preamble. Finding it super relevant. Because one of the things that has been like really grinding in my mind, so the way biometrics is defined in the EU AI Act is only as identification. So authorization applications are excluded. Mm-hmm. And the argument that that is being given is that authentication is sufficiently covered by the GDPR and they don't want duplication. And so, like, which makes sense, can fully understand it. Also, I don't know anything about law, so you have to, like, trust.
Might be better question for my colleague Michèle. She's a legal scholar.
And yeah, so I guess, like, the question it's coming to is that technically identification and verification are almost the same. So if you collect data for a verification application, if you build a verification module, you can very easily repurpose it for identification. And I think even if we come to, let's say, user consent, I think it will be practically impossible to let any normal user just like be able to distinguish whether their voice is being used for verification or identification. On top of that, let's say if you build a model if you have a verification collection happening in Spain, you could build an identification application in South America without any restrictions in terms of UI. So, anyways, now I'm bringing you all my questions. I'm saying I'm trying to figure out is it worth thinking more about this, or is the GDPR really sufficient? Is there more need to really look at this in more detailed ways, or yeah?
As part of the research for this work, I have not seen anything that seems relevant to what you're talking about. And in fact, we've seen very little guidance on how to actually implement these principles in practice. And biometric systems, I have not seen anything about biometric systems. And we do in the paper talk a little bit about the distinction between the procedural purposes and outcome purposes. And I think this is somewhat related to what you're saying, is that the distinction between the verification and the identification, it seems like, what is the outcome of the system, right? Even if in practice, procedurally, they're doing exactly the same thing. So I think it's a very interesting distinction of whether we should focus on sort of on the outcomes or on the process when defining the purposes. Very, very relevant, very interesting.
And maybe a question then from a PhD perspective of saying, let's see what do you think might be a useful way of starting to investigate this?
What is your background?
My background is computer science. I'm an interdisciplinary faculty, so called technology policy management. So I guess I've got access to computer science knowledge, to speech scientists, and to ethics. Legal was a little bit harder for me to come by.
I can tell you a little bit how we approached the topics of the paper that we're presenting here. That was published in a Tech plus Law journal, and it's targeted a little bit more to the legal community. Then we decided to bring this to the FAccT community in the form of this tutorial. And then we published one paper in SIGIR last year that proposed a computational interpretation, and then conducted some simulation studies in recommender systems, saying that, if we implement it in this way, these are the consequences. This is how it's going to work in practice in this particular setting. So then we had this several computational paper, and then we have another paper. In fact, tomorrow my colleague is going to present with a machine learning model that tries to automate sort of compliance with this principle according to yet another interpretation. So if you're a computer scientist, it is definitely possible to approach this in this sort of like multi-angle mode, where you have some computer science publications that propose some technical solutions and perhaps analyze what they might entail in practice, and then target perhaps through collaborations with legal scholars. I have done with my colleague Michèle to analyze the more interdisciplinary aspect and sort of translating between the two. So this is how we've approached this, and it has worked quite well so far.
Really awesome. So if I take a look, let's say, at the 3 papers that come out, I'll be able to also see a nice I'll be able to follow, trace a bit how you've gone about it.
Hopefully.
Okay. Cool. Thanks so much. I'll stay to hear the question.
Sure. Would you mind walking with me so that I can grab some more water?
I was just wondering from a practical perspective, how
Hey, Asha.
Hi, Michèle.
How are we doing? You have a better view of this than I think.
Yeah, I think we're fine. I'm probably going to take 5 minutes to talk about repurposing now, and then we can both take 10 to talk about data minimization.
Yeah. Yeah, that sounds good.
We can maybe start in 2 minutes.
Yeah, sure. I'm just sitting here, so.
Will volunteer for you because my shift is ending,
Mhm.
and she can assist you with that part. I'll just show him some stuff around. Yeah.
Perfect. Thank you so much for your help.
Yeah. Do we need a mic for the questions? Is that right? Somebody may be have any questions. You're okay with the screen share, right?
I think I figured out in the meantime.
Great. Do you have any other questions? I think it should
We'll
work
just
fine.
go for now. Mhm.
Okay, maybe you can just sit in the front.
Let's start. Before the break, Michèle shared the legal perspectives on data repurposing. So I would like to now offer some computational perspectives on repurposing. As we have already mentioned, one of the biggest concerns about purpose limitation and data minimization is that limiting collection of data will inhibit future machine learning innovations. As Michèle mentioned, there are a few conditions under which we can reuse or repurpose data. First of all, we can reuse data when two purposes are compatible. So when could we think of two purposes as compatible in data-driven systems? Under the purposes performance interpretation, and when we measure performance using well-defined metrics, one natural computational interpretation of compatible use is when metrics are positively correlated. And this is just one hypothetical interpretation that we examine in the paper. So consider the following scenario. An online outdoor store originally collected personal data, such as product ratings, to improve the performance of personalized hiking gear recommendations. The store then expands its catalog to include hiking clothing. And it turns out that shopper preferences for certain categories of clothing and certain categories of gear are correlated. For example, through producer brand, price range, or other features that we sometimes use for personalization. The data collected for the purpose of improving personalized gear recommendation will likely improve the clothing recommendations. So we could perhaps argue that it can be used for the latter purpose under compatible use. But an interpretation like this shouldn't be disconnected from the context, because practical implementations would need to account for various issues, for example, spurious correlations or handling of implicit latent features. As I mentioned, this is just one interpretation we hypothesized about in the paper, but there could be others. All right, if we cannot reuse data under compatibility, there are still 3 avenues that Michèle discussed that could allow us to repurpose the data. The first one was using data for scientific research. And an interesting practical angle here would be what can be considered scientific research. Michèle said that in publicly funded and externally published work at academic institutions might perhaps be uncontroversially considered as research, but what constitutes research in private companies is perhaps less clear. Industrial research teams do both internally and externally facing work, with internal research not meant for external publication, but rather for proprietary product development and innovation. To complicate matters further, something that Michèle discussed briefly, various company organizational structures often make it impossible to distinguish who works on research and who works on products, despite official employee titles that might suggest a clear distinction. To provide 2 specific examples, we found this paper that describes the Google organizational structure where research scientists are often embedded in engineering teams. And as a result, many research scientists develop products and many software engineers do externally facing research. We found another description of Spotify's organizational structure. They do not follow a traditional hierarchy, but employees with different backgrounds and titles are organized according to various functional dimensions, for example, system feature areas. So what is scientific research in commercial companies? It's often hard to tell. The second avenue for repurposing data are statistical purposes. And an interesting computational angle here that has been a subject of debate in the machine learning and statistics communities is whether machine learning is just a form of applied statistics. Michèle mentioned that to count as statistics in this particular context, the outputs of a model cannot be personal data, but they have to be aggregate data, and the results cannot be used in support of measures or decisions regarding any particular natural person. So we would have to think about personalized services as individual measure. There is another distinction that is relevant in this context of individual versus aggregate outputs. Namely, machine learning pipelines produce aggregate and individual results at different processing stages. Many data-driven systems leverage large sets of user data to construct a model and then use such an aggregate model in conjunction with an individual's data to compute the individual results. For example, a search engine might train a non-personalized ranker that pre-selects web pages in response to a query, and then use individual user data to re-rank the web pages in this pre-selected set. So in a scenario like this, the training of the aggregate model might be considered a form of statistical analysis, while applying the model in conjunction with an individual's data should probably not be considered a statistical result, but an individual result. One caveat to consider here is that there exist personalization algorithms that do not conform to the above scheme. For instance, personalized recommendations based on matrix factorization techniques might use all individuals' data to train the model and produce personalized results at the same time. So this still has to be analyze in the particular context of a given system. All right, the third avenue allowing us to repurpose data is consent. And here, the major practical challenge of acquiring informed consent for service improvements lies in explaining the value of improved results in comparison to the various costs the collection of different pieces of user data might entail. On the one hand, it is hard to expect that service providers would ask for such fine-grained consent when studies show that users have a limited understanding of the overall digital ecosystem. We found some studies, for example, that show that some users are not even aware that their search queries are collected and stored in the first place. On the other hand, we found existing studies on related problems that show that it is, for example, feasible to directly ask users for their privacy preferences when it comes to feature collection, or indirectly estimate how much users value their data in the context of specific tasks, for example, disease prediction. At the same time, there are several lines of research, including explainable AI or uncertainty and risk communication, which aim at communicating the outputs of a computational system to end users in an understandable way. And while those two lines of research that I've just mentioned on privacy preferences and model output and risk communication are largely separate, it is possible to imagine combining both approaches to design informed consent solutions for service improvements in data-driven systems. An important technical consequence of consent is that data has to be erased once consent is withdrawn, and this can be particularly challenging in case this data was used to train a machine learning model. We have only recently started developing techniques for efficient removal of such data without the need to retrain the entire model. And this is an important problem if we want to be able to enforce the right to consent withdrawal without high economic and environmental costs. Great, Michèle, would you like to talk about data minimization?
Yes. So let me share my slides. Right. So so far we've mostly talked about purpose limitation, but as I mentioned in the beginning, the paper actually looked at both purpose limitation and data minimization, and I think it really makes sense to look at those two principles together, considering that data minimization is really derived from purpose limitation. So it's in many ways, a close cousin of the purpose limitation principle. And we find the legal definition of what data minimization requires in Article 5.1c GDPR, which tells us that personal data shall be adequate, relevant, and limited to what is necessary in relation to the purposes for which they are processed, right? So just sort of this formulation indicates that data minimization is to be assessed vis-a-vis the purpose that has been defined. And specifically, it requires that only personal data that is adequate, relevant, and limited to what is necessary in relation to those purposes be processed by the data controller. So what do those three concepts of adequacy, relevance, and necessity actually mean? So adequacy has been interpreted to mean that only pertinent personal data can be processed for a given purpose. So an example of this would, for instance, be that where a given website wants to provide personalized recommendations to you, that is the purpose of the processing, and they, to that end, collect data about your specific date of birth, including the day and the month. Then that would not be deemed pertinent, except maybe, if you wanted to provide personalized recommendations that have an astrological flavor. But I think that would be an example of, a processing of personal data where the data is deemed not to be adequate to the purpose, to the extent that it's simply beyond the scope of what you actually need in order to achieve the purpose in question. Now, relevance is pretty similar to adequacy, but one key distinction that we draw attention to in the paper is that unlike adequacy, relevance can actually require that in some scenarios more data is processed. And that could, for instance, be the case where your data set isn't representative enough, right? In that context, relevance could actually require that you go and collect more data about a given population group that is underrepresented in the data group in order for the data to be relevant. And this also indicates the sort of close connection between the various core data protection principles in Article 5 GDPR. In this case, we already talked about how fairness can affect how transparency can affect the interpretation of purpose limitation and data minimization. And the example I just gave would be an example of where fairness, another principle enshrined in Article 5 GDPR, would influence the interpretation of the data minimization requirements. And then the final subcomponent of data minimization is the necessity criteria, right? So Article 5.1c tells us that only data that is necessary in relation to the purposes for which they are processed shall be processed. So essentially, this requires that the data controller ask the question, well, what is the minimum amount of data required to achieve the purpose, and that they don't process data that goes beyond what is really needed in order to achieve that purpose. So that's the data minimization principle as it is, I'd say, conventionally understood from a legal perspective. In the paper, we also examined whether data minimization should be understood more broadly, namely to not only require that those adequacy, relevance, and necessity criteria are met when determining what personal data to process in order to achieve a specific purpose, but we also make the case that data minimization also affects the sort of categories of data that should be processed. And specifically, we make the claim that where a data controller has the option between plain text and pseudonymous data, so where both plain text data and pseudonymous data are similarly well suited to achieve a purpose, then data minimization would also mandate that they opt for pseudonymous data as opposed to plain text data. Similarly, we also make the claim that where a data controller can choose either sensitive personal data as defined by Article 9 GDPR, so, for instance, health data, versus ordinary personal data, so any personal data that is not sensitive personal data, they should always opt for the processing of ordinary personal data as opposed to sensitive personal data, where both are similarly well suited to achieve the purpose that they are processing. And with that, I'm handing over to Asha.
Despite the existence of appropriate computational techniques and empirical evidence suggesting that it might be possible to limit data in data-driven systems to a much larger extent, so something I discussed at the beginning of this tutorial, minimization of user-generated observational and behavioral data does not appear to be so widespread in practice. We found a study of software developers' approaches to data minimization, which revealed that practitioners' practices, both in terms of protocols and tools and understanding of the principle, differs, highlighting the need for more specific implementation guidelines. Guidelines for implementing data minimization have been issued by, for example, British and Norwegian data protection authorities. And when we look at these guidelines, we found that they typically offer very high-level suggestions. They would, for example, say that you could use learning curves as a technique when inspecting a machine learning model. But then there's really another step that we would have to take to translate the suggestion of using this technique into a specific algorithm or a definition. They also typically talk about what I would call more structured user attributes, for example, gender or location, rather than data that is generated from user observation. So behavioral data such as clicks or how long a person has inspected different parts of a web page, and so on and so forth. So several open computational questions are a potential reasons why more detailed guidelines for performance-based data minimization in particular are missing. And now I'm going to discuss some of these questions in more detail. The first and foremost challenge lies in determining whether and which data improves a given service results. The state-of-the-art computing knowledge does not really provide off-the-shelf answers. The closest relevant line of work aims at quantifying the impact of individual data points in training sets on the accuracy of machine learning models trained using those sets. And such data points typically correspond to individual persons and are composed of multiple pieces of information about an individual user, so multiple features. To the best of our knowledge, methods that would quantify which specific pieces of data about an individual data subject which of these pieces of data are necessary to improve, for example, a personalized service, either for that individual or globally for all of the users, such methods are missing. What is more determining whether a given piece of personalized data should be minimized out will be a form of prediction about future system performance. And as such, these predictions can reasonably be expected to be inaccurate. And the question remains, what level of inaccuracy would be acceptable here for this form of data minimization, for this approach to be deemed practically viable? Beyond the prediction accuracy, the determination of how much and what personal data is to be kept for a given performance purpose depends on a number of factors. So those include the prediction method itself, the underlying service algorithm, existing user data, but also the entirety of other data at the disposal of the service provider, so the data of other users. And out of these factors, I think two merit special attention. First, data minimization outcomes will largely depend on the underlying algorithm. Advanced systems employing complex models that need to learn many parameters require a big quantity of data to function properly. So by developing and implementing state-of-the-art solutions, service providers might be able to collect more data as a result. On the other hand, we also found work that suggested that infusing vanilla models with domain-specific knowledge might allow for better performance with smaller data sets, and so less overall need for data collection. So these observations lead to a number of questions of economic nature. If less data can be collected with custom models, would companies who can afford an internal research unit be able to minimize data better? If bigger models grant a data processor the right to collect more data, will then companies who can afford the often very costly infrastructure necessary to operate those models would be allowed to collect disproportionately more data because they're actually needed for a good performance of these models? The second factor influencing data minimization that was worth highlighting is the complex balance and interdependence of the data of different users and the system performance for those users. It might be tempting to think of the system data as static when considering which pieces of an individual personal data to minimize out. But the data that is minimized out for a given individual might constitute the system training data for other individuals. So minimization of data for a single user will also influence the performance of the system for other users. And we really need a global systemic approach that at the same time would work for each individual data subject separately. All right, last but not least, setting aside data processors' purposes and for a moment taking the perspective of an individual user, it is important to recognize that different people might have different personal purposes when using a service and generating data. For example, we might have a user who generates a movie rating purely to give the provider the information needed for personalized movie recommendations. And in this case, performance-based minimization might appear appropriate. But we could have another user who generates movie ratings for personal archiving purposes, just to store a log of movies they have seen and they have liked or have not liked. In this case, the storage of all personal ratings would appear appropriate. So as a result, it might be necessary to not only model the purpose of data collection by the service provider, but also the purpose of data generation by the user. And the need to model user personal purposes further branches into two challenges. First, it is rather difficult to infer user intents from their behavior. Recognizing people's search intents from text queries, for example, continues to be an active research problem in information retrieval. And second, users might engage with technology products in originally unanticipated ways. Some people, for example, use email, which is a technology developed primarily as a communication tool. They use email as a task management or archiving system. And inaccurate detection of user personal purposes might lead to both under and over minimization of user data, depending on the context. So that sums up my computational perspectives on data minimization. Michèle, would you like to talk a little bit about the high-level trade-offs in data protection?
Yes. So, as we said at the beginning, what really motivated us to do this kind of research were those persistent claims regarding the impossibility to implement purpose limitation and data minimization in data-driven systems. And as Asha has just sort of underlined, again, the paper then actually shows that, you know, it is possible to implement those two legal principles, even in contemporary data processing systems, so specifically the systems where it's often claimed that, you know, this is impossible. However, that doesn't mean that, you know, our research concludes with sort of a statement that there's no issues and problems here. Rather, as part of our research, we identified challenges and trade-offs that emerge when we try to map data minimization and purpose limitation to data-driven systems that are, in our perspective, under-acknowledged in the broader research community. And I'll mention three of those here. So the first issue that we encounter is the challenge inherent to the generality of legal principles and the need for computationally operational interpretations. So, and this is something that, you know, is really underlined by the research that we've done in this paper, but I think can also be said much more generally in relation to data protection law. So the General Data Protection Regulation and its predecessor, the Data Protection Directive, they were sort of like on purpose formulated as what we call principles-based regulation, right? So the idea was that this shouldn't be extremely detailed technical legislation. Rather, it should be a legal document that sets out various principles that ought to be respected when personal data is being processed, such as purpose limitation and data minimization. And there shouldn't be more granularity to those general principles in the legislative text, because this might sort of prove to be undesirable as technology continues to further evolve, right? So there was really a clear decision as part of the lawmaking process that the GDPR should announce general principles that can be adopted to any technological context, specifically because we are in this time where technology changes at a fast pace. We don't know what's coming next. And the EU legislator wanted to prevent the existence of relatively recent data protection legislation that would then prove to be impossible to implement in respect of a new technology that would only be developed after the GDPR entered into force. Now, that approach has a number of advantages, but the questions that we're asking in this paper really underline that it also comes with challenges, right? So data minimization, purpose limitation, that is general principles, and there's a lot of open questions, as Asha has just underlined, when it comes to determining, how to specifically implement them in a specific technical context. And at this stage, we find that this is something that's difficult to do for data controllers in practice. It's difficult for them to determine whether their interpretation of purpose limitation or data minimization is actually fully compliant with the law. And there isn't lots of guidelines either by data protection authorities, or I think we should either say maybe that the guidelines that exist oftentimes lack the level of specificity that would be beneficial to data controllers in this context. And there's also no, codes of practice or other interpretational efforts that are coming from the commercial side that would help here. So I think this challenge of matching general legal principle to specific computational context is something that can definitely be observed in relation to the analysis that we've done, but that it's also a more general concern that is likely here to stay and will cause difficulties in numerous contexts. Then we also identified a number of trade-offs, and this, for instance, includes the trade-off between data subject rights and the economic and environmental costs of enforcing them. So one example where this really becomes plain is the data subject right to withdraw consent, where processing is based on consent. So Article 7, Paragraph 4 of the GDPR tells us that where a given processing operation is legitimized by data subject consent, the data subject has the right to withdraw consent at any point. And that then means that the data can no longer be processed after consent has been withdrawn. So we look at how to apply this in machine learning models, and we actually find that at this stage, there's no elegant ways of removing one data subject who has removed consents, personal data from a model, short of retraining the entire model. And this, of course, comes with significant economic and oftentimes also environmental costs. And this kind of trade-off is one that isn't really talked about much, right? We don't really find this in the literature or in general debates about data protection law and its implementation. And so we conclude from this that this should be a more active area of research, and also that there should maybe, to start with, be a more explicit acknowledgement of this. And then the final trade-off that we're thematizing in the paper is data controllers' decision that they need to make between the cost of compliance and the unlikelihood of enforcement. So just the last trade-off that I talked about between data subject rights and the economic cost of enforcing them underlines that compliance with data protection law is oftentimes costly for data controllers, right? It's an additional cost that is being imposed on them, and that is I guess fine to the extent that regulation oftentimes imposes costs on various actors, and there's agreement that there's good reasons for doing so. But the costs of compliance coupled with the unlikelihood of enforcement that we're seeing in data protection law, at least at this moment in stage, this is something that might change in the future, but at this moment in time, at least, this is something that we're observing, results in a situation where data controllers will actually, just rationally be balancing cost of compliance with, for instance, purpose limitation and data minimization against the unlikelihood of enforcement, and make decisions based on this. So, of course, this is something that might change as enforcement of data protection law might change in the years to come. But for now, any rational data controller will be trying to balance those costs, and that might mean that they decide that there's simply not sufficient incentives for them to be serious about purpose limitation and data minimization. And with that, I'm handing back over to Asha.
This is the final section of the tutorial. Hopefully, the tutorial has given you an overview of the current state of purpose limitation and data minimization as applied to data-driven systems. The question we'd like to answer now is, what could practitioners be doing right now, and what could the researchers do next? It's heartening to see that there has been a growing interest in this topic in the computational community. If you're interested, take a look at some of these papers. For example, in our paper from CGIAR 2020, we proposed a performance-based interpretation of purpose limitation and what it would mean to minimize data according to this interpretation, both globally at a model level and at the level of individual users. Clavel et al. Analyzed tensions between data minimization and the feasibility of bias audits. When we minimize the sensitive data that is actually necessary to reason about fairness and bias. Rastegarpanah et al. Propose a method for auditing feature-based data minimization, so whether actually providers are doing this in practice. Goldstein et al. Propose a method for feature-based data minimization using anonymization techniques. And Shanmugam et al., this is the paper that a colleague of mine is going to present tomorrow, proposes a machine learning approach to automating data minimization during data collection. Even though the implementation of purpose limitation and data minimization in the context of data-driven systems requires more research, as we have highlighted throughout this presentation, practitioners might consider implementing a range of existing solutions and best practices that contribute toward data minimization. The first organizational best practice, and this is something I think is purpose limitation and data minimization are great for, is for system developers to create and cultivate a mindset of reflecting on the purposes of data they collect. And then continuously reevaluating which data should be collected and when it should be deleted. So instead of just mindlessly collecting more and more without thinking whether we actually need it, just having this mindset of reflecting on this really goes a long way. To quantify the importance of different pieces of data, practitioners can use some of the off-the-shelf solutions for machine learning models, including feature selection, data influence estimation, or data valuation. At the data collection time, techniques such as active learning would allow data processors to prioritize which data is most important for the model's quality. Data can also be minimized through simpler heuristics, such as the selection of representative random samples, selection of data, specifying certain domain-specific quality criteria, or retaining the most recent data only. heuristic that I talked about earlier during this presentation. And finally, minimization should be employed not only at the data collection time, but also continually reapplied and reevaluated throughout a system's lifecycle to all existing data stores. Beyond these practical approaches that we could apply right now, implementation of purpose limitation and data minimization requires more research. We think that to be implementable in practice, these principles will likely need to follow a similar research trajectory as the work, for example, on algorithmic fairness has to date in this community. As demonstrated throughout the tutorial, we need mathematical interpretations of the principles. We need decision rules for deciding which pieces of data are necessary and which should be discarded. We need machine learning models that could automate compliance. We need quantitative data analysis for understanding how the implementations of those principles, according to the different interpretations that we are proposing, might influence the quality and the functioning of online ecosystems. We need standardization of data processing purposes to ensure their specificity and an understanding of how different purposes relate to each other to be able to reason about their compatibility and when we can repurpose data in practice. We lack an in-depth understanding of what value people associate with different types of data in different contexts. We should, moreover, design appropriate transparent mechanisms for collecting informed data processing consent and technical means of removing data from existing models once a purpose has been fulfilled or a user withdraws their consent. We need auditing methods that could establish compliance with purpose limitation and data minimization. And this is a completely different story compared to some of the computational approaches that I discussed here. And finally, we need to establish normatively, legally, and computationally how to balance data minimization with other GDPR requirements, for example, fairness and accuracy, which, as some of the work we discussed today has shown, might be at odds with the minimization principle. As the work on algorithmic fairness has previously exemplified, it is difficult to bridge terminological and substantive gaps between disciplines. We may wonder whether and how legal principles, particularly broad principles such as purpose limitation and data minimization, can be translated into algorithms and code. And without doubt, this is a question at the core of the FAccT community that requires more engagement from multiple disciplines. And we're excited and hopeful to see more work in this area in the future. Thank you. I think we have a mic for the Q&A.
Thank you for the presentation. So I'm a computer scientist, and perhaps my main interest on this topic is checking whether a system has biases, right? For instance, has gender bias, right? And I have found over and over that I go to check if a system has the gender bias, and I find that they have not collected gender information for good reasons, but the data are not there, right? So the Artificial Intelligence Act, the proposal for Artificial Intelligence Act, includes a provision that allows people to collect, for the purposes of ensuring bias monitoring, protected categories of data, right? So it allows for whatever is strictly necessary for bias monitoring to process these special categories of data. Now, from what I heard from Michèle, like statistical analysis of data is allowed within the current framework. And in this case, like checking for bias will be a statistical processing because it will not be individual. It will be something like what's the average salary of men versus women or something like that, right? So my question is whether you think that the fact that this exception in the AI Act that allows the processing of special categories of data for the purpose of bias monitoring somehow expresses that the current framework does not allow the processing of these special categories of data for bias monitoring using these statistical methods. That's my question. I hope it was clear.
I'm sorry, I didn't understand the last two sentences, I think, of what you were saying. So I understood the beginning of the question, but then the line was a bit blurry. So maybe you could just rephrase the very end.
So basically, if in the AI Act, in the proposed AI Act, there is a provision that allows people to process special categories of data for the purposes of bias monitoring, right? For instance, bias against a certain protected group. My question is, the fact that that is there, should that be interpreted as that the current framework, the current legal framework in the EU does not allow the processing of these special categories of data for the purposes of bias monitoring, even if it's done in an aggregate and a statistical way? What's your opinion on this?
Right. Okay. Thank you. So essentially, you're asking whether this provision in the draft AI Act that I think this only applies to high-risk AI systems, right? That high-risk AI systems can be monitored for bias by processing more data means that right now this wouldn't count as a statistical purpose. Is that correct?
Yes, that's my question.
Yeah, not necessarily. I mean, I think we'll have to see what the AI Act looks like in the end, right? I mean, I think this is still very much an open question, and then there's many additional open questions regarding the interplay between the AI Act and the GDPR. But I wouldn't interpret the fact that there's now this specifically acknowledged sort of opening to process more personal data for bias monitoring for high-risk systems, and I think high-risk AI systems only, as an indication that right now you can't do so, to the extent that this would probably be caught by the statistics opening that we talked about before, because you wouldn't be applying sort of the result of this analysis to an individual, but rather take it as an indication of the system overall. So, oftentimes in EU law or generally in legal systems, you might have subsequent legislation that simply sort of builds on prior legislation or renders it more concrete. But I think this kind of reformulation should be understood as an indication that prior to the entering into force of this new legislation, the same activity was necessarily unlawful under the previous legal regime.
Thank you.
Hi, my name is Elisabetta Gavin. I'm working at Carl Leuven as a legal researcher. And first of all, thank you very much for the call. I'm a doctoral researcher at the first year of research, and it's really inspiring to see how this kind of research can be done and presented. I really enjoyed reading your paper. I read the formal version of the publication, and for me it was really foundational for the writing of my PhD proposal about the conceptualization of accuracy in data protection as a principle of data processing. And I have a more legal question maybe, but I understood sometimes that in the paper and the talk refer to trade-offs and tensions between GDPR principles. And also in the findings that you presented, you proposed to study the balances between those principles. So my question is somehow twofold. On the one hand, I would like to understand a little bit better what do you mean by balancing the principles, because I've been thinking a lot about this when I read your paper. If it's relevant to the presentation, how do you see the role of accuracy in the context of purpose limitation and data minimization? Thank you.
Yeah, thanks for that question. I think this is all, those are all really interesting things to think about. So I definitely say that I think that the various principles listed in Article 5 ought to be interpreted together, right? So I think the interpretation so accuracy should sort of influence the interpretation of purpose limitation and data minimization. I don't think we talk as much as accuracy in the paper, but like in the paper we have some examples of where we think that, for instance, transparency or fairness should influence how we interpret purpose limitation and data minimization. I think the same can be said in relation to accuracy. I haven't. Maybe I'm just not seeing it. I haven't thought about this much before, but like I think generally maybe accuracy is not going to be as relevant in relation to purpose to the purpose limitation principle, but in relation to data minimization, I think it is. But I also think that there's room to incorporate that, right? So I wouldn't say that there's necessarily a trade-off between data minimization and accuracy to the extent that we. To the same extent that is the case in relation to the trade-offs that we identify in the paper, right? So for instance, if you look at the subcomponents of data minimization, adequacy, relevance, and necessity, right? And adequacy meaning that only pertinent data is processed, relevance meaning something similar, but also meaning that, in some circumstances, you can actually process more data, such as, for instance, to comply with the fairness objective. I think we can very well incorporate accuracy in this analysis, right? So adequate data is probably only accurate data, right? I mean, I haven't thought about this before, but like it seems pretty obvious to me that inaccurate data would be inadequate data and irrelevant data as well, right? So I do think that Article 5, that there's lots of interplay between the various subcomponents of Article 5, but I also don't see any sort of like obvious difficulties in matching accuracy with data minimization specifically, because I would think that that courts would agree that data that is inaccurate is also inadequate and irrelevant. So probably those work together quite nicely, actually. But maybe maybe you've thought of an example where this isn't the case. I'd be happy to discuss this more now or via email later on.
Thank you very much. I will reflect on this and maybe we'll come back on this. Thank you.
You can also add a computational perspective on this. So to the first part of your question, typically the way we computer scientists would think about balancing of different principles would be that we would encode each of them separately as, say, as an optimization objective or set some algorithmic goal. And we would try to, say, assign different weights to these different algorithmic goals and try to design an algorithm that accounts for both. And of course, there's a question of how to balance those weights, like how much importance to put on the different ones. That would be an open question here. Specifically in relation to accuracy, some of the interpretations that I discussed today that tie the processing purpose to the performance of a model, that's related to the accuracy of the model. So in the past, we have proposed two specific definitions for what that might mean in practice, like how to minimize data in relation to a purpose goal. One of the definitions ties, say, the collection of the data to the overall performance of the model across a number of different users. And we could say, for example, that, well, data minimization in this case might mean that we stop collection once we achieve, say, 95% of the overall accuracy that we can hope to achieve in a given setting. Another interpretation that will be presented in this paper I mentioned tomorrow looks at the predicted performance curves of an algorithm and says once the slope of this performance curve flattens, so that means the algorithm is actually not learning so much, and if we're adding more and more data, we're hitting these diminishing returns. So let's stop once that slope is below a certain threshold. So these are two of the ways in which a specific definition might tie data minimization to accuracy.
Thank you very much.
Thank you very much for the great tutorial. So I have been meaning to learn about data minimization for a long time, but had not got time. And thank you for covering all these topics. I have two questions. The first question is probably more related to the legal perspective. In case of repurposing of data, there was this question of academic research versus industry research. So in terms of exceptions, so there is exceptions for research. Now, in that case, is the question really about for-profit research and not-for-profit research? I mean, could this be defined in that way? And coming to the second question, so the three requirements for data minimization. The first one, adequacy. Now, here I have a question about how do you really figure out how much data would be adequate for a machine learning system? And in fact, this would be a bigger question in terms of online platforms. Now, today you might be thinking that this much of data is adequate, but tomorrow with new users and new items on the platform, it might be inadequate. How do you think about sort of long-term modeling for the adequacy perspective or the requirement?
You can maybe start with the second question. Is that okay, Michèle? Right. Of course, this is just my own interpretation, but the way I would think about adequacy is by defining all of the goals that the system would have to achieve. So accuracy might be one, but you might also want to be fair to different users. You might want to allow people to discover new content that they perhaps might not be even aware is there, so perhaps wouldn't be captured through standard accuracy metrics. So once we're able to identify all of these goals, then we could say, instead of looking at this one particular goal of achieving good performance, let's look at the system more holistically and try to collect all of the data that would allow us to satisfy all of the different goals and make sure the system benefits the user. That's just one interpretation. There could be others. And when it comes to the future goals, maybe Michèle, you could comment on this a little, because my understanding is that it is not possible to argue that we are collecting data for unknown future purposes. And so arguing that we might have new users in the system in the future whom we don't know who they would be, how they would behave, what goals they would have, it would be really hard to argue that we have to collect the data for these future unknown purposes. But Michèle is probably better positioned to talk about that.
Yeah, so thanks for those questions. I have to admit that the connection has been a bit tricky for me for the last 2 minutes, so I hope I understood all of the questions correctly, right? So I think the audience question was about the interpretation of what scientific research is for the purposes of the GDPR and what that means for our context. So in the GDPR in its recitals, I think it's recital 159, tells us that scientific research should be interpreted in a broad manner, right? As far as I recall, there's this provision sort of explicitly lists some examples of research, such as definitely fundamental research, but also applied research and privately funded research. And so the general indication that we're getting from the text of the regulation itself is that scientific research should be interpreted in a broad manner and is not just fundamental research that is, publicly funded in a publicly funded university context, but there's definitely a broader understanding of this that also includes privately funded research. And even though sort of the analysis of what the legal interpretation of research should be is not sort of one of the focuses of the paper, so we don't go into examine this in an extraordinary amount of depth. But what we are wondering about specifically in the paper is, considering conventional understandings of research and, considering the I guess, state of how most research was being done at the time the GDPR was negotiated, we're asking the question, whether the mixed teams that are made up by product people, but also people that do research and have a sort of title like research scientist, etc., to what extent this can actually be included, and to what extent their collaborative work would actually be caught by the research regime under EU data protection law. And we think that this is very much an open question. So we're not really speculating about what we think the right answer to that question would be, but we're I guess predicting that this is definitely one of the difficulties of applying the law to contemporary organizational structures.
Just to follow up on that, it would be right to assume that even in cases of academic research, the output of academic research, if it is applicable for the industry to use it for profit, that also would be an open question for the research exception.
I don't think so, because the data processing operation that is covered in that context would be the sort of fundamental public research that is being done. And I think, there's no question that would be covered by Article 89, for instance. So I don't think that would be controversial.
Thank you very much for the answers.
I think we're at time, so I would suggest if people have any more questions, I'm happy to stay longer and answer them, and I'm sure Michèle is happy to answer any questions related to the legal perspectives over email or perhaps on the platform. Thank you everyone for joining. Thanks, Michèle.
Thank you.